Here's a little problem that again popped up on my Facebook feed. I seem to be inundated with these things. I'm just going to go through this particular example of a geometric problem whereby we've been given a circle, and inside the circle we have three perpendicular lengths, 4, 6 and 8 centimetres, and we're asked to find the radius of the circle. When I first looked at this, I was a little bit like, I'm not really sure where to start. And then I realised that the right angles were the big giveaway. It's kind of a subtle nod towards using a coordinate system. The fact that right angles means that I can generate a coordinate system for my 3 points where the vertical and horizontal lines touch the outside of the circle, the circumference. So I'm going to put a point here. I'm going to call this A. I'm going to put a point up here. I'm going to call this B. And I'm going to put a point here, I'm going to call this C. Okay, we have another vertex up here, which I'll just call D, because I'm going to use that shortly. So we now have 4 coordinates, or 4 points, and we can arbitrarily select an origin. Now, to me, it's logical to select A as the origin, not just because I've labelled it A, but because vertically above it, we have point B, so the x value 0 here would also be a 0 point up here. So it just simplifies the calculations when I'm going to go ahead and use simultaneous equations from the equation of the circle. So that's going to be 0, 4, because it's 4 high. And then finally point C down here. I'm not going to label the coordinates of D because I don't need them. I know it's 6 along, so I know it's got an x value of 6. And I also know that it's 4 below the, which you can't see, 4 below the x-axis. Because it's 8 below this point D, which is 4 above, so I know it's 6, negative 4. Okay, so there's our coordinate system, which we're now going to use to implement some algebra to find the radius of the circle that we've actually, you can see drawn there. Okay, so here we go.
So, okay, as discussed, we've labelled some points A, B and C with coordinates using our coordinate system, and I've also got a point D up here, which is the other vertex, because obviously we have the length AB is 4, BD is 6 and CD is 8, so our coordinate system allows us to then create a circle through those 3 points. This is called a circumcircle. So 2 points wouldn't be enough to uniquely define a circle. You need a third. So if we select from the menu circle through 3 points, I'm going to click on C, then I'm going to click on A, and you'll notice my third point could be anywhere to create a circle, but of course it's going to be anchored to B. So we've now created the circle that we're interested in, the circle for which we've got to find the radius. Now there are 2 ways of doing this. There's the way using the 3 points algebraically to solve simultaneous equations, which I'll go through shortly. But also there's another cunning way, which I've only just considered. So what we have is a chord AB, and we also have, if we draw it in, a second chord, AC. So if I draw AC in as a second chord, now there is a circle theorem that basically states if you bisect 2 chords and then draw a perpendicular line through both those bisections, they will intersect at the midpoint of the circle, the centre of the circle. So what I'm now going to do is I'm going to find the midpoint of BA or AB and the midpoint of AC, and then I'm just going to move this out of the way so you can actually see we've done that. And I'm now going to put a perpendicular line through point E and a perpendicular line through point F. Okay, and we basically have 2 equations of those 2 lines, and where they intersect will be the simultaneous result of that. So we can basically find our center point using some simultaneous equations of this first line intersecting with this second line. Okay, and that will be our point G, which is the center of a circle. Okay, so we're going to go ahead and do that now.
Okay, so here are 3 points A, B and C, labelled with the circle passing through them. and we are going to use the general circle equation. So we don't know the centre. I know it's going to be somewhere around here. I'm just going to put a cross there and label that A, B, which is our centre point. So the general equation of the circle is x minus a squared plus y minus b squared equals r squared. That's r squared that we're interested in. So what we're going to first do is we're going to sub in the coordinates x and y 0, 0 for point A. So put 0 in place of x, we get negative a squared, or should I say a squared because it's obviously squaring a negative, plus negative b squared plus b squared equals r squared. So that was using our coordinate A. We're going to call that equation 1. Okay, next we're going to sub in coordinate B. Okay, so now we've got again 0 for x, so once again it becomes a squared plus, and now it's going to be y minus, sorry, try that again, rewind, y is 4 minus b squared equals r squared. Okay, that's equation 2. And then finally, we're going to put in point C, which is down here. So now we're going to end up with 6 minus a squared plus, it's going to be now negative 4 minus b squared equals r squared. Okay, there's our third equation. So we can now go ahead and solve those simultaneously. It looks like it's going to get a bit messy, so I'm going to start a clean sheet for this one. Okay, so here are our 3 equations. The first thing I'm going to do, I think, is sort of relatively straightforward, is I'm going to equate 1 and 2, because they are both equal to r squared. So in this case we end up with a squared plus b squared equals, and obviously I'm going to equate that to a squared plus 4 minus b squared. Okay, and now I can obviously eliminate a squared from both sides, which is really convenient. I end up with b squared equals, I'm going to expand this out, so it's going to be 4 times 4 is 16 minus 8 lots of b plus b squared, and once again I can subtract b from both sides, b squared from both sides, so that's effectively 0, so I end up with 16 equals 8b, so conveniently b is equal to 16 over 8, which is 2. So there's one of our unknowns, and we're going to go ahead now and equate 2 and 3, so 2 equals 3, and see what happens with that. So we've established b is 2, and we're just in the process of equating equations 2 and 3 now. So equation 2 is just a squared plus, now we know, let's multiply, we know that b is equal to 2, so if we put b into 2 in there, we end up with 4 subtract 2 squared, which is 4, and that equals r squared, which is also equivalent to equation 3, so we know that that's going to be 6 minus a squared plus, and once again we've got negative 4 subtract b, so it's going to be negative 6 squared. Close the bracket in the right place. Okay, so negative 4 subtract 2 is negative 6 squared is 36. Okay, so we're going to expand out our 6 minus a squared on the right hand side. We get 36 minus 12a, bit of a glitch there, minus 12a plus a squared plus 36. Okay, so conveniently our a squares disappear once again. We're going to get 72 on this side. Okay, so 4 is equal to, let's do this step by step, 72 minus 12a. Okay, I'm going to subtract 4 from both sides and add 12a, so I get 12a equals 68. So a is equal to 68 over 12, which becomes 34 over 6, which is 17 over 3. So a little bit more awkward, but we now have a value of a. Let's write this up here. Oops. One more attempt at that one. 17 over 3. Okay, so all that remains now is to find r squared by subbing our values of a and b. So here we go. Okay, so I've left equation 1 up there with the values of a and b because equation 1 is the easiest one to work with. So we're simply going to sub a in. Awkwardly, it's 17 over 3. So 17 over 3 squared plus 2 squared equals r squared. I'm going to clean this up a bit. Top of my head, I think that's 289 over 9 plus 4. I think I can manage that one. Is r squared. So 289 over 9 plus, so we're going to make this over 9, so it's going to be 36 over 9 gives us our 4, that's r squared. So r squared is equal to 289 plus 36. So add 6 is 295. So 325 over 9. So r is equal to the square root of that. So I know that that's going to be 3 and root 325. So 25 goes into 312 times, that's 13 times. Okay, so it's going to be 5 root 13 over 3, I believe is our final answer for r. So I'm going to go ahead and check this in a minute on GeoGebra, but I'm just going to go ahead and do my other version of solving this problem, which actually could turn out to be easier. Let's find out. Okay, so just a reminder, what we've done here is we've bisected the chord AB and the chord AC, and we've got those points E and F, and then we've drawn a perpendicular line, and through one of the circle theorems, the intersection of those two lines is in fact the centre of the circle, which is point G. So again, we're going to label those points A and B like we did before. So let's just work out the equations of these lines. This is really straightforward. It's horizontal and it passes through point E. So point E is halfway between A and B, so it's literally y equals 2. Okay, so that was really not much of a struggle. And we also have the second line up here, which is going to be y equals mx plus c. Okay, so we want to be able to work out the gradient of that line. So I know it's perpendicular to the line AC, so I'm going to call this gradient m1. Okay, so if it's perpendicular to that, i.e. this is 90 degrees, I'm going to call that gradient m2. So gradient m1 is simply our change in y from A to C. So I'm just going to start with C, and we're going to do, from A 0, subtract negative 4, over 0, subtract 6. So that gives us negative 4/6 or negative 2/3. Okay, so because it's perpendicular, I know that it's going to be the negative reciprocal of that, so it's going to be positive 3 over 2. So I know one part of my puzzle for this equation. I know y equals 3 over 2x plus c. Okay, and I also know it goes through point F being here. So if we can work out the coordinates of point F, I'm going to do this down here, give myself some space a bit later. It's basically the midpoint from A to C, so we know that it's going to be 3 along in x, because difference between 0 and 6, and negative 2 in y, so that's pretty straightforward. So I'm going to sub in 3, negative 2, so negative 2 is our y value, equals 3 over 2 lots of 3 plus c. If I simplify that, I'm going to end up with, I'm going to do that's negative 4 over 2 equals 9 over 2 plus c. So c is going to be equal to, subtract 9 over 2 from both sides, I end up with negative 13 over 2. Okay, so a little bit awkward. So we now have our full equation, y equals 3 over 2x minus 13 over 2. Okay, so that is my second equation. So literally have this equation and this equation to solve simultaneously. It's actually not too difficult to do, because all we've got to do is sub 2 in place of y. I'm going to do that on my next slide. Okay, so we have our two highlighted equations. Y equals 3 over 2x minus 13 over 2 is our diagonal line, and our horizontal line y equals 2. which basically gives us our value of b. So we already know that our y value, the centre of the circle, is actually 2, so b is equal to 2. It's just a case of now finding the x value, or a. Okay, so we're going to equate these two. So I'm going to say that 2 is equal to 3 over 2x minus 13 over 2. And I'm going to solve for this. So that's going to become 4 over 2 plus 13 over 2 equals 3 over 2x. And we can now combine these two. We end up with 17 over 2 is equal to 3 over 2x. So cancel our 2's through, and x is equal to 17 over 3 as before. Okay, so that's encouraging. We ended up with precisely the same set of coordinates. So our centre point is going to be 17 over 3, and we can go ahead and do some Pythagoras once again by joining our point A to our centre and working out the length r that we're looking for. Okay, so we don't need to do that because we've just done it previously and we've got the same x and y values. So I'm going to do the big reveal now and see if we end up with the correct value which we just calculated. Okay, so there's our geometric situation with the circle and the two bisecting lines going through E and F, passing through our centre point of the circle G, which has coordinates 5.67, rounded to dp, comma 2. That's the same as 17 thirds and 2, so that's correct. So I'm now just going to join a segment between A and G, which is going to give us our radius, and we're going to actually work out that distance, or rather I'm going to click on the calculation to work out that length. Okay, so this is not going to be in surd form. Remember we calculated 5 root 13 over 3. It's saying 6.01. I've literally just calculated the decimal value and it's 6.009, etc. So yeah, we've smashed that one. Okay, two different ways. I think you might all agree that the second way was a little bit more efficient. Okay, thank you for watching.